Morning, everybody. Can you
Morning,
hear me?
sir. Yes, sir.
Can you see the screen okay?
Yes, sir.
All right. So I see a lot of persons not here as yet. I didn't really want to. Didn't want persons to miss what we're doing today. But the time was set from a long time ago, and the session is being recorded. And so I'm gonna start. All right. All right, let's give them a minute. Let's give them a minute. One more minute and then we'll start. Let's give a minute. Okay. All right, so a number of persons have jumped on. Number of persons. So let's get going. But you can hear me still? Good to go?
Yes,
Just
sir.
checking. All right, everybody can see the screen well. All right. All right, let's do this. All right, so this was our classwork that we did. The last class activity. So I'm just going to run through it quickly, and then we're going to look at some past papers, all right, for additional practice. So they gave us these two functions, that's f of x, that's g of x. This one we call it a rational function. It's in the form of a ratio, like a function divided by another function. Well, it's a power function because it can be written as x plus 3 to the power half. It can be written like that. The square root is really when the power is a half. All right. That's why we're writing it as an index. All right. And then they ask us the normal things. First, I want g of 6. So g of 6 means that we want to put 6 in the g function right there. Simple as that. All right. So that's pretty straightforward. So A, I want to find g of 6. So to calculate the value of g of 6, which is the image of the value 6 on the function g, we do the square root where this x is, we're going to put 6 there plus 3. 6. So this is where the x was. So put in 6 there now. That becomes the square root of 9. Square root of 9 is 3. Done. G of 6 is 3. Part B. Part B wants f of g of 6. Remember, f of g of 6 means that we have to do g of 6 first. But we already worked out the g of 6. It is equal to 3. This is the same g of 6 here. So this f of g of 6 then becomes f of 3. Because, as I said, the g of 6 right here is 3. Because we worked out the g of 6 already and it is 3. So there's no need to work out the g of 6 again. And so we're now doing f of 3. And f of 3 now means that we're going to put 3 in the f function. 3 is coming here, 3 is going there. We're going to put 3 in the f function and work out the value. So that is going to become 2 times 3 minus 7 divided by 3 plus 1. So all we did, replace this x with 3 and replace that x with 3. And this is 6 minus 7, that's a negative 1. That's 3 plus 1 is 4. So the result is negative a quarter, minus 1 and 4. Next part now wants us to work out f to the minus 1 of negative 1. All right, that's it. That's the function f. So we need the f to the minus 1 first. So let's look at it. For part C1, we're trying to find, let me put out the trying to find in red first. We're trying to find f to the minus 1 of negative 1. How we're going to do it? We're going to do f to the minus 1 of x first. And then we can work out the f to the minus 1 of negative 1. And so we have to calculate the inverse of this function f. Inverse of it, f to the minus 1. So the process is the same. You interchange in the domain and the range. So first, I'm going to write back the function. It's just that I'm going to leave off the of x expression. I'm going to write it as f. Some teachers just call it y. All right, but I'm going to call it f because it's function f. I'm just going to call it f. So I'm going to start by saying f equals 2x minus 7 divided by x plus 1. This is the function as presented. In this function as presented, this f represents the range of the function. The x here, those two x's, they each represent domain. They represent the domain on the function. When you form the inverse function, the domain becomes the range of the inverse function. And this range is going to become the domain of the inverse function. So this second arrow thing means that I'm forming the inverse function. This is the range of here, it becomes the domain. In the inverse, we're forming the inverse function. This range becomes domain. Domain is written with the letter x, with the x. Equals. The x here and the x here, they are range on this, domain on this function. They become range in the inverse function. So I'm going to put back the 2. This x is domain now, it becomes range on the inverse. Range on the inverse is written f to the minus 1. Minus 7 comes back. You're dividing that by this domain again becomes range, which is f to the minus 1 plus but this one. So this is the inverse function I've formed. I've formed the inverse function. It's just that I don't yet have f to the minus 1 as a subject. You want the range expression for the range to become the subject. So we're trying to find the f to the minus 1. So then, to do that, you have to transpose to make f to the minus 1 a subject. First step is to expand it out into separate terms. We don't want this fraction. We don't want to have it dividing itself. We want to expand it out into separate terms. Then group all the terms we want on one side. Terms we want will have f to the minus 1 in it. Group all of them on one side. Anything we don't want, we put it on the other side of the equation. And then we're going to factorize out the f to the minus 1. It's the same steps all the time when we have a rational function like this. So the first step is to take this denominator and multiply it across here by the x. It is the same as saying we are multiplying both sides by f to the minus 1 plus 1. And multiply the right side by f to the minus 1 plus 1. And then this one cancels that. That's a long way to do it. But the shortcut way to do it is simply to say we multiply this denominator across here by the x. Shortcut method to do it. So let's do it shortcut. So multiply it across by the x, it becomes x times the denominator. X times the f to the minus 1 plus 1. We'll call it cross multiply. F to the minus 1 plus 1. That becomes equal to the numerator remains what it is. 2 times f to the minus 1 minus 7. Then it's a matter of expanding this. We could have done this by multiplying this straight by the x, but let's go step by step. I'm going to expand this now. So it becomes x. Why are we expanding? Because remember, I want to separate out all the terms so that we can group terms with f to the minus 1 on one side, because we're trying to make f to the minus 1 a subject. So we're going to get x times f to the minus 1, and then x times the 1 is x equals 2 times f to the minus 1 minus 7. Then we're going to leave this on this side because it has f to the minus 1 in it. This f to the minus 1, or 2 times f to the minus 1, I'm going to bring it on this side of the equation and change the sign. This x, we don't want it over here. We're going to take it on this side of the equation again and change the sign. Note, however, that this is a negative 7, not just a 7. We're not moving it, so it will remain a negative 7. All right, so let's write the next line now. So I'm going to keep this on this side of the equation, which is x times f to the minus 1. This is going to come over onto this side and change sign, the minus. So it becomes a minus 2 times f to the minus 1. All right, I'm going to put equal. This negative 7 doesn't become a 7, it remains negative 7. And this x that was on this side, because it is positive, when it comes over here, it's going to become a negative, a change sign. It becomes a negative x. And so we have now grouped the terms with f to the minus 1 on the same side. We want to make it the subject. What do we do with it? We factorize it because we only want to see it one time. So we're going to factorize it in order to see it one time. Want it only to appear once, so we can make it the subject. So we're going to factorize it. We're going to factorize f to the minus 1. Out of this, we get that x. Out of this, we are left with a negative 2. And the right side remains the same. Minus 7 minus x. And then now we want to leave this as a subject, so we need to get rid of this. Shortcut is to say we divide it under here. Long method is to say we divide both sides by x minus 2, such that this one cancels this one. It's going to end up with this just the same. I prefer shortcut. We need to understand what is really happening behind the scenes. You're dividing both sides by the x minus 2, but shortcut is just to divide it under here. So we're going to get f to the minus 1 equals negative 7 minus x divided by the x minus 2. I removed it from the bracket. You don't need to put it in the bracket. And so we have formed the inverse function. We now have this as a subject. So the same of x that I left off here, I left it off there. I'm just going to put it back now. I'm just going to put it back now down here and put in back the of x. Let's put it in a red color so we can see that we'll put it in there. So this is now f to the minus 1. So I've completed this first thing that we said we're going to do. Find f to the minus 1 of x. Now that we find f to the minus 1 of x, we want f to the minus 1 of negative 1. So now it's just a matter of substitute the negative 1 in here, in there, and in there to get f to the minus 1 of negative 1. Everybody good so far? Everybody okay so far?
Yes, sir.
So we can say therefore f to the minus 1 of the negative 1. Mute your mic, please. Mute your mic. From negative 7. Mute your mic, please. Minus. A lot of people made mistakes right here. You have to put back this minus first. And then now the x value that you're replacing is negative 1. Right? So you're placing negative 1 for that x. Negative 1, I mean, negative 1. So this x is negative 1. So the minus minus here becomes a plus, and you're dividing this side. This x is negative 1 minus 2. We have to be careful with these negative signs while doing the questions. So this really becomes negative 7 plus 1, you know. This minus minus in front of the 1 really becomes a plus. This really becomes a plus. So then it is negative 7 plus 1. Negative 7 plus 1 becomes a negative 6. So this becomes a negative 6 on the numerator. Then negative 1 and negative 2 gives us negative 3. And now we really just dividing. Hold on a second. Right? We're really now just dividing negative 6 by negative 3. The negatives cancel each other. And so we get 6 divided by 3 is 2. And so we end up with f to the minus 1 of negative 1 is equal to 2. That is the answer right there for this part of the question. Nice and easy. The next part wants us to find g to the minus 1 of 1. Let's write it down again. So for part 2 and section C, we're trying to find g to the minus 1 of 1. That's what we're trying to find. That's right. What's the steps? We're going to find g to the minus 1 of x first. We're going to put the 1 in it. Then we're going to put the 1 in it and do g to the minus 1 of 1 and see what value we get. What function are we working on? We're working on this g function. We're going to inverse that g function. All right? So let's start by just calling it g for now. So we're going to say g equals the square root of x plus 3. I'll just leave off this again for the time being, the of x expression there. It's just an expression really. Just leave it off for the time being. And then this is our function. It's a similar thing that we inverse it. We're going to inverse it. Similar to the f that we did a while ago. This g represents range right now. It becomes domain on the inverse function equals the square root. This x represents domain on the function. It becomes range in the inverse. Range in the inverse of g is written g to the minus 1. And then put back this plus 3. Plus 3. And so that is it. So we have formed the inverse function. We just need to make this a subject. So the first thing is to move the square root sign. To move that square root sign, we do the inverse of what square root is, which is to square. So basically going to be squaring both sides. Square this side and square this side. When we square the right side, the square root sign will be eliminated. Right? When we square both sides. So when we square both sides, let me take off those red marks. Right? The left side, when I square both sides, this side, we square both sides, this becomes x squared. And the right side is just g to the minus 1 plus 3. But understand that? We'll square both sides. Got to go to that?
Yes, sir.
Yes, sir.
All right. And then we're trying to make this a subject. Now it's just a matter of moving this 3 over here. And leave the g to the minus 1 as a subject. So the g to the minus 1 becomes equal to x squared. When we transpose this positive 3, it becomes negative 3. So this is g to the minus 1. We can now put in back of x, g to the minus 1 of x. But what we really want? We really want g to the minus 1 of 1. So we're going to plug the 1 in there. So we can write it and say, therefore, g to the minus 1 of 1 means that we're substituting 1 in here, so we're substituting 1 there to get the value. So we'll get 1 squared. We'll put the 1 here, we get 1 squared minus 3. 1 squared is 1 minus 3. 1 minus 3 is negative 2. So this is the answer. G to the minus 1 of 1 is negative 2. Are they good so far?
Yes, sir.
All right, good. Next part wants us to find g of f of x. G of f of x. All right, let's look at it. So we're now trying to find g of f of x. It's a composite function. G of f of x. What does it mean? It means you're substituting the g into the f. Because it's like you're applying g to f, you know, so you substitute the g into the f. So what do we mean by substituting, not the g into the f, the f into the g, sorry, the f into the g. This is the first function, this is the second one. Remember, g of f means f followed by g, right? So to calculate the composite function g of f, you substitute the f into the g. This one, which is the first one, into the second one, all right? So let's draw it out on the diagram over here, what we're gonna do. Let's draw it out in red to get that composite. We're gonna take all of the f, which is all of this. We're gonna go and substitute it for the x that is in the g. We're replacing the x. We're not putting it beside the x, we're replacing it. All right, simple as that. That's how we form the composite function. Everything else stays where it is. The square root sign stays and the plus 3 stays. We're replacing the x with the entire function f. Simple as that. All right, so this becomes equal to putting back the square root. Everything must be under the square root. Where the x is, I'm putting all of f there, which is 2x minus 7 over x plus 1. This is where the x was a while ago here. It's no longer there. I've replaced it with all of f. And then now I'm going to put the plus 3 beside it because there was a plus 3 beside the x. So we'll get a plus 3 now beside that function. And that's the answer. Everything is squarely under the square root sign as it was here. Over here, everything was under the square root sign and the plus 3 was separate from the x. So the plus 3 has to be separate from the f that you have replaced the x with. That is the answer. But I go to that.
Yes, sir.
All right, good. That finishes that question. Next question down here is that they gave us a sketch. So diagram is a sketch of this function. So this curve is a function. And they label it for us f of x. And they say they pass through the origin and they pass through the point 3, 3. Why did they give us these 2 points? In particular, this one. Because the question asks us to redraw the sketch and to show the inverse function on it. It also tells us to draw the line which represents the relationship between f and f to the minus 1. That line is the line y equals x. It also asks us to state what the relationship is. The relationship is that they reflect each other in the line y equals x. And the line y equals x passes through these points. It passes through those points. Right? So let me just do it on this diagram right here. Let me zoom it up and do it on this diagram. Let me zoom it up. Do it right here on this diagram. Right on the screen right there. So the first thing I'm going to do, because I'm going to draw the inverse, and I know the inverse is obtained by reflecting in the line y equals x. You reflect the function in the line y equals x to get the inverse function. So I need to see that mirror line, that line y equals x. I need to draw it first. It passed through 0, 0, and it passed through 3, 3. So that's why they gave us those points to help us draw that line. So I need a straight line passing through those points, a straight line, and extend it all the way out. That's my line, y equals x. It's curvy on this diagram because I cannot draw a straight line with this device, but it's a straight line I'm drawing there, passing through these points. And label everything you put on the diagram. So the line is y equals x. So I've drawn my mirror line. To draw the inverse function now, I have to reflect this one in this line. Best reflection I can draw. A reflection. So points on the line will stay on the line, because if you reflect something, if you put your finger on a mirror, the image of your finger also will be on the mirror. If you put your nose on the mirror, right at the point where your nose touches the mirror, the image of your nose is also on the mirror. So if you reflect a point that's on a mirror line, it will remain on the mirror line. That's why these points remain on the line. Right? Now, this function, this part of the function that goes under the line, when you reflect it, it's gonna go above the line, same distance, like that, almost the same distance. Looks like a reflection. That's what it's gonna be. If I reflect this part of the line, it is as if there was a point here, and this point here was, for example, 1. So this point was 1. That can't be 1, 1, because 1, 1 is here. So this point was 1, 1, 0.5. So this point was 1, 0.5. The image of this point over here would be 0.51. The values are switched around. So at point 1, 0.5, and this piece would reflect to 0.51. The values switch around, the coordinates switch around. All right, because the domain becomes the range and the range becomes the domain. You have to remember that about the function and its inverse. All right, and then this part of it now up here, we need to reflect that as well. Reflection of this part up here must be somewhere out here, so it's like a reflection. Draw it over. Or something like that. If this point was, say, 4, 5, then this point, where this point reflects to, is now 5, 4. That's how it is, right? That's how it is. And yeah, 4, 5, you know, maybe something like, say, 4, 8. This point was 4, 8. Then the reflection would be 8, 4. 8, 4. That's what it is. So I've drawn the function and its inverse. Let me take this off. But they did not give us these. If you look at it, it's supposed to look like you're reflecting the graph. Then all I need to do, since this one is f of x, just label this one f to the minus 1 of x. Label it. And that's it. Looks like a reflection. The red line looks like a mirror line between them. The red line is like a mirror line between the two graphs. But I understand that? But I can see that?
Yes, sir.
All right. When you draw it, it should look like a reflection. But that's the relationship between them. So this line, the question says, draw the line which represents the relationship between them, between the function and inverse. That line is a red line that I drew, y equals x. That line represents the relationship between them. And it asks us to state what the relationship is. Relationship is as shown on the diagram. They are reflections of each other in the line y equals x. F to the minus 1 and f, these two functions, they are inverse of each other, and they are reflections of each other. If you reflect this one, you get this. And if you reflect this one, you get that. That's what the two functions are. You reflect this one to get this one. and you reflect this one to get that one. What are you reflecting in? You're reflecting in this line. So any one of them, you're reflecting in line y equals x to get the other one. So we say something like they are reflections of each other in the line y equals x. That is the relationship. And put it in purple. I'll put it in red. The relationship between them. State the relationship between f and f. What's the relationship? F to the minus 1, or f, write it out this way. F of x and f to the minus 1 of x. Any function on its inverse are reflections of each other in the line y equals x. That's it. That's the relationship between a function and its inverse. Any function and its inverse, that's the relationship between them. If it's g of x and g to the minus 1 of x, same thing. If it's h of x and h to the minus 1 of x, same thing. Any two functions which are inverse of each other, the relationship between them is that they are reflections of each other in the line y equals x. Because when you reflect in the line y equals x, coordinates of a point will reverse, they switch around. They switch around. So again, if I have a point here, and the point here is 4, 8, if I reflect this point in this line, the coordinates will go and switch around to 8, 4. So what was the domain is now the range, and what was the range is now the domain, the trade places. That's what the line of y equals x does for you when you're reflecting it. It reverses the coordinates, switch around the domain and the range. So the function was mapping 4, the function f was mapping 4 onto 8. The inverse is now mapping 8 onto 4. That's how it works. But okay?
Yes, sir.
All right, so I just wanted to explain. All right, so that ends this question now. That ends this activity. So now it's a matter of jumping onto some past papers. All right. So let me do it like this. Let me do it like this. Let's do it like this. So we can just practice some past papers. We still have some more functions to do tomorrow. Some other stuff that we're gonna do in functions. All right. All right. So let me start with the exam this year, 2023. Let me start with the 2023 exam this year. So you can see what the standard is like. 2023. This paper, I think it is. There's a function question from this year. You know what? I don't want to do this one. I'm going to leave this one for next week. Simply because it speaks of undefined. When the function is undefined. And this is something I want to do in the next class. I want to explain it next class before I do it. I'll do this one next week, or do the second revision on functions. Right? There are a few more things we're doing in functions tomorrow, and this is one of them. When a function is undefined. So let me not do this one. Let's do another one. Let's do 2022, June 2022 instead. Let's look. I'll do this one next week. All right, so 2022, June 2022. Where are you? All right, that's this right here. All right, there's a functions question. I'm gonna say that they're pretty normal, very easy. All right, this is a show marks topic. Should be getting full marks on these questions. Right? Sometimes a functions question come in section 1, sometimes a come in section 2. All right. Sometimes they come in section 1, sometimes they come in section 2. So this question gives us these two functions, f and g. All right, f and g. And it says for the functions given, we have to determine g of a third. G of a third. So we're going to substitute a third in the g function right there to get it. Simple as that. So this becomes equal to 3 times a third, where the x is, we put a third. And then subtract 1 again. 3 times a third is 1. So we get 1 minus 1. So the answer here is 0. So g of a third is 0. Done. Easy. All right. Next question. They want f to the minus 1 of negative 3. What we're going to do? Same thing all the time. Other ways to do it, but I'm doing it this way for now. When we master functions a little bit more, then I show another way to work this out without calculating the inverse function. But we're going to do f to the minus 1 of x first. That's the method we're using. Then we will do the f to the minus 1 of negative 3. So what is the function f? Function f is this, 5x plus 7. So let's write it. Let's go back for the blue. 5x plus 7. F is 5x plus 7. So f is 5x plus 7. So the of x that was here, I'm just leaving it off for the time being. All right. I'm going to inverse that. The f, which is range, becomes domain, equals 5 times this x, which is domain, becomes range in the inverse function, f to the minus 1, plus back this 7, plus 7. So this is our inverse function we have formed. We just need to make this a subject now. Easy. We're going to move this 7 over here first and subtract it, and then we're going to divide by the 5 afterwards. So we'll have to move the 7 first and then divide under the 5. So that easy thing. So we're going to get f to the minus 1 equals, move over the 7 first, it becomes x minus 7. And then to move x minus 7, sorry. And then to move this 5, we divide it under, divided by the 5. So this is f to the minus 1 of x now. Okay, I'm putting back off x now. So f to the minus 1 of x is that. So from this now, we can calculate this now, f to the minus 1 of negative 3. So we can say, therefore, f to the minus 1 of negative 3 means I want to put negative 3 inside here. So we're going to get negative 3, that's where the x is, we put the negative 3 minus 7 divided by 5. This is negative 10. So that becomes negative 10 over 5. Negative 10 over 5 is negative 2. So this is my answer right there. Nice and easy. But they're okay with that?
Yes, sir.
Yes, sir.
All right, beautiful. Anything else? Question done. Question is finished. Let's look at 2021. So the question is easy on the exam paper. These are actual exam papers we're looking at now, right, guys? So you should be building your confidence that the question is easy. Remember, we're finished. You need to go and redo all these questions by yourself. Redo them again. Do them over. Do them by yourself. Just remind me to send the papers in the group. Right? Remind me to send the papers in the group. And the video is being recorded live on YouTube, and you can use the video to help you. I'll send a link to the video in the group as well. All right, so this is 2021. This is January 2021. June 2021. On June 2021. Doing the June ones first. So June 2021. Where are you? Right here. There's another functions question on past paper. This is 2021. All right. This is the 2021 exam. So they give us these two functions. This is f and this is g. That's a rational function. All right. This is a normal linear function. They want f of 9. This is the f function. So you're going to put the f in the 9 in there to get f of 9. All right? Don't lose marks on this. So f of 9 becomes equal to f of 9 means I want to put 9 here. So it becomes 1/3 of 9 plus 4. 1/3 of 9 is 3. 3 plus 4. 3 plus 4 is 7. It's 1 mark for it, but we want the 1 mark. We want it. Every mark count. 1 poker full basket. All right? Let's look at this one now. We want f of g of 3. F of g of minus 3. Remember, this means we're going to do the g of minus 3 first. Because remember, it means g followed by f. This can be done 2 ways. You can work on the f of g. You can work on the f of g of x first, f of g of x first, and then plug the minus 3 in there. Or what we can do is calculate what the value of g of minus 3 is first. So this is the same as f of g of minus 3. So it means that I want to work out the g of minus 3 inside here first. We're going to get the g of minus 3. Because we're going to plug the minus 3 in the g function right here, where the x is, to get the g of minus 3. I'm going to put minus 3 in the g function. All right? And so we're going to get f of, and we're working out the g of minus 3, and it becomes 3 times minus 3 over minus 3 plus 1. But go do that?
Yes, sir.
Good. Then it's going to become f of this become negative 9 over negative 2. So it becomes f of, it becomes 9 over 2. The negatives cancel, so we get 4.5. Or we can leave the 9 over 2. So the negatives cancel. So we're working out f of 9 over 2 now. What does that mean? It means that we're going to plug the 9 over 2 into the f function now. We're working out f of 9 over 2. Right? Working out f of 9 over 2. So we're going to plug the 9 over 2 in the f function where the x is. So it's going to become, we're going to put some, move this and get some space. Move this and get some space. Let's get some space. Let me shift this. Okay, let me shift it over. Like a smaller. All right, I'm gonna continue right here now. So from here now, we're gonna work out f of 9 over 2 by plugging the 9 over 2 inside here. So we're gonna get a quarter equals a third, sorry, and 9 over 2 is the x value. And you're adding 4. So that's what we're working out now. So this becomes 3 over 2. Because 3 into this 1 time, 3 into this 3 times, it becomes 3 over 2. So it becomes 3 over 2 plus 4. 4 is the same as 8 over 2. How did I do that? This 4, I multiply it by a 2 and divide it by a 2. As I want it to have the same denominator as this one. So it's the 4 times 2 becomes 8. So leave that on the screen. Then when they have the same denominator, can just add the numerator values. And so the final value is 11. 11 over 2. 3 and 8 is 11. Common denominator of 2. That's it. Are you okay with that? But all right?
Yes, sir.
Yes, sir.
All right, good. Let's continue. Is there anything else? All right, look at this one now. So determine the value of x. Let's see, we want to find a value of x. All right? When g of x is 5 over 2. We want when g of x is 5 over 2. So look at it. Remember that this is g of x now. So we want when this equals 5 over 2. So we'll now solving this. G of x equals 5 over 2. That's what we're solving. When g of x equals 5 over 2, that's what it's solving. 3x over x minus 1 equals 5 over 2. That's what it means. All right, so let's go and do it. So write it here and then move it down to show you. If you're solving g of x equals 5 over 2, and this is your g of x right here, then you're really solving 3x over x plus 1 equals 5 over 2. You really know solving this equation. That's what you're solving. All right, so let me copy that down and continue. That's what it means. Copy. All right, so I'm going to write that this means that, right? It's down here. So I'm going to say IE, that is, and then paste what we copied down. That's what it means. Because this side is a g of x equals 5 over 2. So how do we solve this now? You can do a cross multiply thing. See, into trying to make x a subject, so we need to expand it out into separate terms. Group all the terms in x on one side. So to cross multiply first. So what we're gonna do, we're gonna take this denominator and multiply it up here. And take this denominator and multiply it up there. Cross multiply to get rid of the fractions. All right. So we'll cross multiply to get rid of the fractions. We're gonna get 2. Let's write it out for you. We're gonna get the 2 times 3x, or 3x times 2, same thing. 2 times 3x equals, and then this comma multiplied by the 5. So it becomes 5 times x plus 1. So cross multiply. This side becomes 6x equals, this side becomes 5x plus 5, or expand. This 5x comes over and subtract from the 6x. So it becomes 6x minus 5x equals 5. 6x minus 5x is just 1x, or x. So that says that x is equal to 5. This is the answer right here. So x is 5. If g of x is equal to 5 over 2, x is 5. But I go to that calculation. Are they okay?
Yes, sir.
Yes.
All right, I think that finishes this question. All right. So I want to do another question now, but I'm selecting this particular question because I want to be able to show you something. All right, something that we have not yet encountered in the class. All right, so sometimes we learn things in practice. We learn the basics, but then there are things that we learn in practice. All right, so when you come up in the question, I'll show you, and then I'm going to show you one additional thing after that. Well, let's do it in let's look at it in practice first. So what I want to show you is actually on the January 2021 paper. So let's find that one. So we can learn from practicing. That's why we have to practice, because sometimes there are things that you don't get an opportunity to show in the class, but it comes up in practice. That's why you have to practice. And then if you are practicing and you come up on a question and say, sir, so you didn't show us this, and they send a message that you asked me. I say, well, we didn't do any examples with that yet. I know that by the time we get to the exam, but we're going to be doing all the past papers, then we will eventually get to all those things that are not so frequently set. There are some things that are not frequently set. So you're not going to see them every day, but you still have to know them. And you get to those things by practicing a lot. That's why we have to practice. So let's look at this question. When I get to that unique thing, I'll show you. So they give us 3 functions in this question. They give us a f of x, they give us a g of x, and they give us a h of x. This one is 5 to the x right here. H of x is 5 to the x. Zoom it up so you can see it. All right? This is actually an x right here. All right, that's 5 to the x. All right. So let's look at what I want us to do. First thing wants us to find f of a half. Easy. Substitute the half in the f function right there to get f of a half. All right. So this becomes 2 times half minus 1. Let me make the pen a little thinner. Hold on. Let's make the pen a little thinner. Just give me a second. Yeah. So again, it's gonna become 2 times a half minus 1. 2 times a half is 1. It's like the previous question. 1 minus 1 is 0. So CSEC, you repeat questions all the time. I set questions that are similar. All right, let's see what does they want us to do. They want h of 0. How do we get h of 0? I'm going to plug 0 in the h function right there for the x. That's the h function. H of 0 means 5 raised to the power 0. 5 to the power 0 is actually equal to 1. Any number raised to the power 0 is 1. If you like, you can test it on a calculator if you didn't know. Any number raised to the power 0 is 1. All right? So that's something good to know. But your calculator can work it out for you if you didn't know. Just put 5 raised to the power 0 in the calculator, and the answer is 1. So again, this one is now finished. Done. Nice and easy. What is the one? The one g squared. So this is what I want to show you now. G squared of -3. So let me pause for a minute now and show you something about this squared thing. All right. So g squared of x does not mean that you're going to square the g of x. So in this question, g of x is equal to, let's write it, is equal to 3x plus 2. This does not mean 3x plus 2 squared. I put a big X on it. Does not mean that. So let me put that out there right now. Does not mean that when we're doing functions. What it means is that I put g into itself. So g squared of x really means g of x. So you're compositing g on itself. So it would mean that you're putting g back into g. So it's almost like you have 2 g's. So you have another g of x right here. G of x. Same 3x plus 2. And this means you're taking one of them and substituting into the x of the other. G into itself, g into g. And so if I were to form that composite function now, then it would be, if I'm forming this composite function by doing this, then what is the result? The result is 3 times, where the x is right here, I'm putting back all of g, 3x plus 2. And then I have to put back this plus 2 at the end, plus 2. But understand that? That's g into g. That's what the g squared stands for, the square. But understand that?
Yes, sir.
And then you'd have to work this out to completion. But I'm just leaving it like that for now. You could expand it out now, and then the 3 is 9, that's 9x. 3 times 2 is 6. 6 and 2 is 8. So this will be plus 8 if you were to work it out. Let me leave this on the screen. I can maybe use it and show you. All right? So the g squared equals this. Now, what if I were to use this now to answer this question? It would mean that all I need to do now is substitute the -3 inside here as it is there, which you can do. So let's just complete it. That this will become, no, then you can write the g now. So this is g squared of x. All right? So we can say, therefore, g squared of -3 would become 9 times -3 plus 8. Now 9 times -3 is -27 plus 8. That will be -19. Now let's do this another way and see if we get the same -19. Because we're using the same principle and same concept, that this really means g of g. Then we can write the answer. This really then means g of -3. I'm going to do the g of -3 first inside there. So how do we get g of negative 3? We have to put the negative 3 in the g function. Grab it here. Put the negative 3 in the g function right there. And write back another g for you right here. G of x. Write it back for you. Write back another one for you. G of x is g of x is 3x plus 2. So this would mean that I put the minus 3 inside here for the x. So if we work it out, we're gonna get this equal to g of 3 times minus 3 plus 2 inside the red bracket. I'll put by the red bracket so you can see it more clearly. Inside the red bracket. I'm working out the g of minus 3. All right, what do I get inside here? Minus 9 plus 2 is negative 7. So I'm now working out g of negative 7. I'll put by the red bracket again so you can see it more clearly. How do I get g of negative 7 now? Plug back negative 7 in g again to get g of negative 7. So that would be 3 times negative 7 plus 2. 3 times negative 7 is negative 21 plus 2. Negative 21 plus 2 is negative 19. Same negative 19 I got here, doing it that way. So I've done this question 2 ways for you. I did it by finding the g squared of x first. That's what I did here. And then plug the minus 3 inside the g squared of x. Right? Put the minus 3 inside the g squared of x there to get an answer of negative 19. This other method over here is where I use the g squared as g of negative 3. And then work out the g of negative 3 first. Because g squared means g of g, which means g followed by g. So you use g and then you use g again. But understand that? But good at that?
Yes, sir.
All right. Then this part down here now wants us to do a composite right here. Wants us to do g of f. G of f. Let's just try them out so we can construct it. So g of x, remember, is 3x plus 2 and f of x was what again? What was f of x again? F of x was 2x minus 1. 2x minus 1. 2x minus 1. So we're doing g of f of x. That's what I want here, g of f. But g of f means f into g. Can't go wrong. Putting f into g. This is f. When I take the f and put it in the g right here, where the x is. That's how we're going to form the f into g. I'll take that substitution and put the f into g. Let me shift this down a bit. So start that out of the way. And our resulting setup is going to be equal to this 3 first. Then where the x is, I'm going to put all of f, which is 2x minus 1, plus back this 2, plus 2. And I can work this out and get a final value, because I say simplify, in simplest form. So 3 times 2x here, so it's 6x. 3 times minus 1 is negative 3. Negative 3 plus 2 over there is negative 1. So it's 6x minus 1. This is my answer right there. The second one. But okay with that?
Yes, sir.
All right. Now there's one more thing I want to show. Oh, there's another question on this. Another one down here. Wow. Okay. Other parts. They want g to the minus 1. All right. They want g to the minus 1. So let's write back the g again. G is 3x plus 2. I'm going to write, I'm trying to find this. I'm going to write that G equals 3x plus 2. I'm going to inverse it. G, which is range, becomes domain, equals 3 times the x, which is domain, becomes range. G to the minus 1 plus 2. So I just need to make this a subject now. Easy. Q over the 2 first, subtract it, and then divide under the 3. Simple as that. So my G to the minus 1 is going to be x. Q over the 2, we get x minus 2. Divide under the 3. Divide under the 3. That's G to the minus 1 of x. I can write it now. I can say, i.e., that is G to, I can put it back my of x right here. Put it back the of x right here. And I can write it now. G to the minus 1 of x is this. X minus 2 over 3. That's G to the minus 1 of x. X minus 2 over 3. All right? And down here now says, hence or otherwise, determine the value of x when G to the minus 1 of x is equal to 4. Now, G to the minus 1 of x is equal to 4. Well, this is the G to the minus 1, you know. So, what this is saying, i.e., this is really saying this, i.e., this equation is really saying x minus 2 over 3 equals 4. That's what you're solving. You're trying to find the value of x. So you're trying to find this value of x. So we're going to solve for x from this. So we're going to multiply the 3 first and get x minus 2 equals 12. We're going to add 2 over here and get x equals 12 plus 2, x equals 14. There are other ways to do it, but I'll show you another way to do it. Quick and fast. Watch this. I'll show you something. Something that we're going to do in class tomorrow. I'm going to show you still. Watch this. It's in purple just to show you. Watch this now. I'm solving this using another method. Just purple and do it. If G to the minus 1 of x equals 4, it means that G to the minus 1 maps x onto 4. Therefore means that x is equal to G of 4. That's how the inverse works. You know? If G to the minus 1 go from x to 4, then G is going to take you from 4 back to x. So the x value that I want is actually equal to G of 4. What did I get? I got 14, right? Let me calculate G of 4 and show you. What was G of x again? Let's write it down. Remember, so G of x equals, what is it? 3x plus 2 in. So to get my G of 4, I just plug 4 into here. So see, you get 3 times 4 plus 2, which is still 14. So you see the x is still 14. So the important thing to realize is that this means this. Them two don't mean each other. Something good to know, which is something we want to cover tomorrow. If G to minus 1 of x is 4, then the x right here becomes G of the 4, the inverse. So the inverse function take x onto 4, then the function G will take 4 back onto x. That's how it works. Think you understand that, students? Think you understand that? It's something I want to do tomorrow. All right? And it can be used to solve the equations. I'm going to write a little statement down here and show you, even though we don't do it yet. Something that just apply. Look at it. If f of x equals some number n, any number n, then it implies that the x inside here is equal to f to the minus 1 of that number n. It's almost like you take the inverse on this side. So if x is mapped onto n using f, then n is mapped onto x using f to the minus 1. And go the other way around as well. If f to the minus 1 of x equals some other number m, then it implies that the x inside here is equal to f of m. What that means? If f to the minus 1, take it from x to m, then m go back to x using f, the inverse. That's how the inverse and its function working. The reverse mapping. Put it another way. Put it another way. If x is mapped onto some number n with the function f, then f to the minus 1 is going to take it back the other way. Take it from n back to f, to x. Right? So this is saying f of x, this statement appears. It's saying f of x is equal to n. That's what it's saying now. And then this statement now is saying f to the minus 1 of n, right here. F to the minus 1 of n is equal to x. F to the minus 1 of n is equal to x. That's how it works. All right, guys. But we're going to do more of this tomorrow. But when we get the opportunity to teach you something new, it's a problem. All right. The more you know, the better you are at this subject. But good so far? But
Yes,
okay?
sir.
Yes, sir.
All right. More maths equals better maths. The more we do, the more you learn. The more you do, the more you learn. All right. Let's look at 2018. So I'm skipping over a couple of papers because we're going to do some of the papers I'm skipping over. I'm going to do some of the papers I'm skipping over next week because there's some questions and that I want to do. But before we move on, there's one additional thing I want to show you now. Good things to know. Good things to know. The more you know, the better. So let me show you something else now. And bring it up on a clean sheet. Let me show you. I can show you right here. Let me just zoom up right here and show you something. More maths equals better maths. Let's practice. The more you know, the better. That's why I have to do a lot of work outside of class. Class is just to cover the basics. Right? After I learn the basics, you can figure out some of these things that I'm showing you now. But then it's easier to just know them. I don't have to figure them out. Watch this now. F to the minus 1 of f of any number is equal to the number still. Anybody think they can explain why that is so? F to the minus 1 of f of a number equal back the number. Because look at it this way. Remember, you do this first. Remember, say this composite function means this followed by this. So we'll do this first. And then we'll do this after the second. All right. So what this is saying is that if you carry out an operation on A with F, right? Then F to the minus 1 is going to reverse what you did. So you're going to carry back to where you started. Let's look at it this way. So like you have a value A, and you put F on it. When you put F on it, it takes you over to some number. Takes you over to some number N. That's what the F does. Take it from A to some value N. Then if you put F to the minus 1, because this is going to become N. I know you're doing F to the minus 1 of N. So if you do F to the minus 1 of N, then F to the minus 1 is going to take you back to A. If you apply F to the minus 1 to the result of what F did, that's why the answer is back to A. Right? But you understand it now, guys?
Yes,
So like you
sir.
carry out a function and a value and you reverse it. You reverse it. Right? That's what it is, you know. You carry out a function and a value. You do f of a and go somewhere to n. And then you use this and reverse it. So this will bring it back to a. That's what does that mean. So that's why this is something good to know. So for example, if I put some values on it, down here, f, put some values on it. F to the minus 1 of f of 3 is just equal to 3. No working out needed. Because f to the minus 1 and f, if you composite them, you're not moving. Like you move it and you move it back. F move the 3 to somewhere, and f to the minus 1 move it back to 3. So f to the minus 1 of f of 3 is just equal to 3. Right? Okay, function does something to it, and the inverse reverses what it did, what the function did. All right, so that is something else I wanted to know, guys. Right? F to the minus 1 of f of a number is just, if I reverse these two and put the other way around, f of f to the minus 1 of a still equal to a. Because these two are inverses of each other. It's just how they are represented. F to the minus 1 just means the inverse of f. But they are inverse of each other. The inverse of this is this, and the inverse of this is that. They are inverse functions of each other. So if you calculate the inverse function, f to the minus 1, and then you go calculate by the inverse of f to the minus 1, you're going to get back f. If you calculate the inverse of f to the minus 1, you're going to get back f. They are inverse functions of each other. Right? So this holds true as well. All right, just wanted to tell you that. So put it in a head, guy, make it stick. But they actually give questions like this, you know. They'll give a question like, what is f to the minus 1 of f of 2? And say state, you might just state it. You can have to calculate nothing. Answer is 2. Answer must be 2. Right? Let's look at another paper, paper, 2018. Let's look at 2018. 2018, let's see. So I'm looking for May, June 2018. Practicing the recent exam papers. I want us to get comfortable with all the exam questions are set. We are preparing for this exam. I want to get comfortable and familiar with how the questions are written. All right? So this is another question, kind of set out a little bit different way, right? I think maybe before the class is over, we can maybe look at a couple of multiple choice questions. Just to see how the functions questions are set on a multiple choice. Those are some of the ones that they might give you a lot of mapping diagrams and so on. So I'm going to jump and look at the paper 1 or 2, the functions questions, and then just to see how those functions questions will appear on a multiple choice paper. But let's look at this one. All right, let's look at this one. This one, you will learn some from this one as well. All right. So this function gave us a function f, and it says the domain is this. So this is the domain, you know, guys. You know what the domain is? These are your x values. It means that since your domain is 1, 2, and 3, it means that your x values can only be 1, 2, and 3. Those are the only x values. Like you have a mapping diagram, and this is the x. The domain 1, 2, 3 in the mapping diagram, and they're gonna map over to some function of x. And this is the formula mapping them in between here. Formula mapping them is half x minus 3. This is the formula that's going to work for what 1 maps to, what 2 maps to, and what 3 maps to. That's the thing. You have to understand that. No other value. This is defined as your domain. No other value can go in there. No other x value can go in there. Because the question is defining your function on this domain. Right? This is your domain A, right here. No other value can go inside there. No other value is accepted. X cannot take any other value than 1, 2, or 3. Only those three values can work, but they are defining what your domain is. Most times with the functions question, they don't give you a specific domain, and so you can use any X value. But when they specifically define your domain as this, it means that you are not allowed to use any other X value in there. And this X value is gonna map to a Y value over here. This one is gonna map to 1, and this one is gonna map to 1. I'm gonna use a mapping diagram to illustrate what I'm talking about in this question. So I'm specifically picking out this question to illustrate some additional information about the function. So here the question is asking us for f of 1. So to get f of 1, we're going to plug 1 in the function right there. All right, so let's work it out. All right, I'm going to leave this mapping diagram on the screen right here, so we can use it. All right, so f of 1. So f of 1 is going to be half times 1 minus 3. That's negative 2.5. Let's work it with the decimal. Keep it simple. That's negative 2.5. But this is 0.5 minus 3. Let's put it as minus 2.5. I'm going to work with decimal this time, just for so. So let me put the value inside in the mapping diagram now. We're going to show the full shebang on this question. Negative 2.5. So that's mapping diagram. All right, negative 2.5. Let me write it in here. Negative 2.5. So show the mapping means that 1 maps to negative 2.5 using the function f. So this is a domain, and I call it A. Let's write the A on it. Since them call it A. Call it domain A. The domain is A. And this is our f of x range over here. And we have worked out that 1 maps to negative 2.5. But understand that? That's what this means. F of 1 is negative 2.5. Means that 1 maps to negative 2.5 using the function f. Are you good with that?
Yes,
Are you good
sir.
with that? Good. Next part wants the value of x. Watch this now. The value of x for which f of x is equal to negative 2. What value of x? In other words, which of these values of x map onto negative 2? Means negative 2 is over here now. One of the values over there now. I want to know which value of x map onto the negative 2. So the mathematics is going to work it out for us. Remember that this is f of x now. It's going to replace this with the f of x to work out what value of x equals negative 2. So see here now, this is asking what value of x make f of x equal negative 2. To work it out, we'll just write what f of x is. F of x is half x minus 3. I want to know when it is equal to negative 2. This side is f of x. What we're going to do, go over this 3 first and add it. You're going to get half x equals 1. Okay, you're going to get, go over the 3, you're going to become a plus 3. And the 3 minus 2 is 1. Then now, to get x now, we're going to multiply by the 2. So you're going to get x equals 2. What does this mean? This means x map, it means x value of 2 map onto f of x value of negative 2. X map onto f of x. So it means the 2 right here, so map onto negative 2 over here in the range. So we can put the negative 2 in there. So map on the mapping diagram, I'm going to put the negative 2 in there. I will now know that 2 map onto negative 2. 2 map onto negative 2. So one thing we don't know is what 3 map onto. But understand that so far? But understand that so far? We're trying to do this question
Yes,
to
sir.
understand the thing and not just by working out stuff. We want to understand it and not just by working out numbers and values and formulae. want to really understand what is happening behind the scenes. When you understand it, you can answer any question regardless of how they want to shape the question. You want to understand, not just be doing. All right, let's continue. Question says, an ordered pair for the function is expressed in the form AB. So what are the ordered pairs so far? One ordered pair is 1, negative 2.5, and that's one ordered pair. If we were to write them out, 1, negative 2.5. An ordered pair says, using your answer, look at it saying, using your answer in A, part 1 and part 2, otherwise, list the ordered pairs of the function. We only have 2 of them so far already. We have one ordered pair here already, 1 map on to negative 2.5, 2 map on to negative 2. We don't yet know what 3 map on to. What we have to do to know what 3 map on to? Because they told us that 3 was a part of the domain, you know. They told us. So tell me now, guy, what do we have to do to know what 3 maps onto? What we have to do? Somebody tell me. Somebody tell me what we have to do to know what 3 maps onto, what value 3 maps onto. Somebody unmute the mic and tell me. Hello? Guys, it's easy enough. If you want to know what 3 map onto, you put it in the function. Put it in the function and the function tell you what it maps onto. This function is mapping x values onto f of x values. That's what the function does, you know. It maps these domain values onto values over here. So I don't have all the other pairs yet. I know so 1 map onto negative 2.5. I know so 2 map onto negative 2. To complete all the ordered pairs based on this domain, I need to know what 3 maps onto. 6 is not going to tell you that you have to work it out. You know, you have to know that you have to work it out. So I have to put the 3 now in the function to know what it maps onto over here. Right? So we have to work that one out. They didn't tell us, but we have to work it out. So we can work it out right here. So we can work it out. I say also, let's work it out. Then they didn't ask us. Let's say also f of 3 means we will work out what 3 maps onto, working it out, equals half of 3 minus 3. That's negative 1.5. Okay, this is half of 3, which is 1.5 minus 3. 1.5 minus 3 is negative 1.5. So it means a negative 1.5 is the next value inside here, the range value. That 3 maps onto. 3 maps onto that. So let me write it in there in the mapping diagram. So this is negative 1.5. I will say 3 map onto it now. See it here? 3 maps onto that value. That's the mapping diagram for this function, you know, on this domain. So this is my domain, this is my range. What that mean? No other value can go in the range. You can have other value in the codomain, but the range is only these values in the range. These are the values that the function map onto. So those are my pairs. That is 1 pair, it's a 2nd pair, that's a 3rd pair, the ordered pairs. So if I'm going to list them down here, so 1 pair is 1, negative 2.5. That's this pair. Put it in the bracket. Write it better. 1, negative 2.5 in the bracket. That's the 1st pair. The 2nd pair is 2, negative 2. And the 3rd pair is 3, negative 1.5. It's them 3 things that the question asks us for, you know, the pairs. Peter, I cut it. Paste it down here. So that's what this asks for down here. And this question is asking us for the pairs. 3 pairs. See there? An ordered pair of function is expressed like this. See, I've expressed all of them like that. I would know that's how we express the pairs all the time, like a coordinates of a point. It says using your answer in part A, 1 and 2, or otherwise we have to work on the 3rd one. You know? It says list list the ordered pairs of the function. See them here, 1, 2, 3. 3 ordered pairs. Think you understand that, guys?
Yes, sir.
All right, I must be learning from this, improving our knowledge of this thing. Questions like this that are not just straightforward and normal. Watch this part now. It says, explain why f of x is not equal to 5 for the function on page 3. Explain why f of x is not equal to 5. Anybody can tell me why f of x is not equal to 5? Remember, f of x is a range value, you know. It's a range value. Explain why f of x is not equal to 5. Cannot be equal to 5. Explain. There's 1 mark for it. Easy. Got the mapping diagram. Mapping diagram. Anybody want to tell me why f of x cannot be equal to 5? All right. Because for this domain, none of these values map to 5. So 5 cannot be in the range. It's not in the range. 5 is not in the range. And you see it here. 5 is not in the range. So f of x cannot be equal to 5. F of x can be this, it can be this, or it can be this. Because those are the values that are in the range. 5 is not in the range. 5 is not in the range. Even when we list the ordered pairs here, so 5 is not one of them. For this given domain, 5 is not in the range. Let me write it out for you. For the given domain, which is A equals 1, 2, 3. The range is, let's go, the range is, and this is the range values now. What are the range values? Minus 2.5, minus 2, and minus 1.5. 5 is not in this range. Five is not in there. This domain give you this range. 5 is not in the range. So therefore, f of x cannot be 5. 5 is not in the range. Therefore, f of x cannot be 5. Because 5 is not in it. This is the range of f of x. Let me shift this over and write. The range is f of x equals this. Let me write it. Shift this over. I don't have to write the statement exactly like this. Anything you write that is saying something similar to this. That's what it is. So basically what we're saying is that f5 is not in the range. The domain values, none of the domain values map onto 5. The domain values all map onto these values. These domain values, they map onto these values. None of them map onto 5. So therefore, 5 cannot be one of your range values. It's not one of your range values. Range values are these. Understand that, guys? Let me show you the domain value where 5 would give you. If you put f of x equal 5, you get a value that is not one of these. You put f of x equals 5. What does f of x again? Half x minus 2, half x minus 3, right? So if you put half x minus 3, half x minus 3, if you try to put f of x equals 5, and put half x minus 3 to f of x equals 5, and then try to solve for x, you're going to get an x value that is not in the domain. Transpose this, we're going to get 8. I get half x equals 8. Multiply by 2, I get x equals 16. 16 is not in your domain. 16 is not. So look how you write it. 16 is not a member. You cross it, not a member of A. Where A was a set 1, 2, 3. 16 map on to 5, you know. But 16 is not a part of your domain. So you can't accept 5 because 16 is not a member of your domain. In order for 16, in order for 5 to be in your range, 16 would have to be in your domain. 16 would have to be one of the values in A. 16 is not in there because 16 is what maps onto 5. Think you understand that, guys?
Yes,
You
sir.
understand that? Okay. All right.
Sir, a little bit, sir.
You understand a little bit? Well, that's all learning is, you know, guys. A little bit at a time. We call it progress before perfection. That is why you have to practice more. The more you practice, the more you get better at it. So all mathematical principles can only be fully understood. That's what I said, you know. All mathematical principles can only be fully understood by doing what? By solving many questions. That's how you fully understand maths. You can't just do 10 questions and fully understand it. When you do just 10 questions, you'll understand it to a point. When you want to fully understand it, you have to practice many questions. Questions that are set up from all different angles, all different ways. Then when you put them all together, you get the full understanding. It's like a puzzle. And you're putting in small pieces in the puzzle. And as you put in the pieces in the puzzle, and you get closer and closer to the end, you start to see the full picture of the puzzle, the more pieces you put in. Till there comes a point now, you actually, you finish the puzzle, you finish the puzzle quick. In the beginning, it is difficult to find the pieces to fit in the puzzle. But as you complete the puzzle by putting in all the pieces, what is putting in all the pieces? Practicing questions and learning small things along the way. And as you get close to the end, you can see the full picture. And you complete it more quickly, you complete the puzzle more quickly. That is why, you guys, you have to practice. All mathematical principles can only be fully understood by solving many questions. That's why you have to practice. The more questions you do, the more you understand it. The more you understand it. And the more you understand it, it's the more able you are to answer questions when CSEC or anybody try to twist up the question a little bit. Okay, you understand it to a level. You get me? That's how it is.
Yes.
All right. That's why you have to practice. I encourage you to practice. Mathematics is the doing subject. Mathematics is the doing subject. You have to do questions. All right. All right. What time is it now? I have about 30 minutes left. So I want to just look at a few multiple choice questions, just to show you how those questions are set up as well. All right. We're gonna do a lot more questions over the time, you know, in terms of functions, paper 2 questions, but I want us to just have a quick look at a multiple choice paper or 2, just to get a feel of how the functions questions appear on them. Let's look at, let's see what we have here, one of the most recent ones. All right, let's look at June. This is 2023 right here, you know, 2023. It's 2023 paper, you know, just gone the other day. 2023 multiple choice paper right here. Let's see if it look clean. Some of them not so clean. This one look clean enough. See, this is a June 2023 paper, you know, you're looking at. The very last multiple choice exam that was set just the other day. Multiple choice. Mr. Shaw is very resourceful, I can tell you. All right, let's see a functions question. This right here is a sets. That is sets. Let's see. That is sets. They set a lot of sets questions, but on the sets don't come on paper 2. It comes on multiple choice. So sets is a topic we're gonna do later on, closer to the exam. It's not on paper 2, but it's on paper 1. All right. So you see a good number of sets questions there. Looking for the functions, looking for the functions, looking for the functions. Let's see. They all come together. They're like in one section. When you see them, they're like all together in one section. Let's see. When we find that section on this paper, is the same section of questions on the other papers as well. Let's see. All right, look at this question now. Here's a function question starting at 47, right? Let's remind ourselves where it starts. All right, start at 47. Look at this question, guys. Question says, which of the following graph represent a linear function? A linear function. Which of them is a linear function? Which one do you think is the answer? Anybody?
B.
Which one do you think is that? B? Somebody said B. Anybody else?
I think it's A.
All right, somebody said A. All right, watch this now. This one actually is not a function. Remember, guys, when we get the function in a graph, we have the vertical line test and we have the horizontal line test. We do the vertical line test first. The vertical line tells you it's a function or not. Now, a vertical line on this graph, let's zoom it up. A vertical line on this graph will intersect at an infinite number of points. So remember now, guys, any graph that has a vertical section on it is not a function, because then it becomes a one-to-many relation. If you think of a point here and a point here, so go to x coordinate here says 2, and the y coordinate here says 4, and the y coordinate here says -4. Then it means that this point is 2, 4, and this point is 2, -4. What that means? It means that the value 2 is mapping to 4 and also mapping to -4 on this line. If that line is a relation, that's a one-to-many mapping. One-to-many is not a function. Has to be many to one or one-to-one. But just remember, once a graph has a vertical section on it, it's going to fail the vertical line test. So this is not a function. It is linear, it's a line, but it is not a function. So this cannot be the answer. The question is asking us for a function. That is not a function, it's a line. No, the others are functions. So that one is not a function. So let's leave that because it fails the vertical line test, right? So this one is a function because any vertical line I draw on it, you cross it at one point only, but it is not linear. It's not a line. It's actually a many-to-one function. Because I'm going to do the horizontal line on it. It's going to cross at 2 points, so it's a many-to-one function. This one is a function as well, pass the vertical line test. And it's a one-to-one function because any horizontal line I draw on it for the horizontal line test to tell me what kind of function it is. Any horizontal line I draw will intersect at only 1 point. So this is also a one-to-one function. Well, guess what? It's not linear because it's a curve. So this is the answer. A is the answer for this question. That is the correct answer. It's a line, it's a function because it passes the vertical line test. Any vertical line I draw on it will cross that only one time. Any horizontal line I draw also will cross at only one point. So it is a one-to-one function and it is a line. So it is linear. A is the answer. A is the answer. All right? A is the answer. I don't want you to know it by guessing. I want you to know it by understanding. I don't want you to know it by guessing. Know it by understanding that this one is not a function, but it's a line, it's linear, but it's not a function. This one is a one-to-one function. This one is a many-to-one function. This one also is a one-to-one function. This is a one-to-one. Let me mark them. This is one-to-one, a one-to-one function. This is a one-to-one function as well. This one is a many-to-one function. Shift it over. This one is a many-to-one function. Right? But this one is not linear, not linear. That's not a line. That is why this one is not the answer. This one is linear, because it's a line. This one is a line, but it's not a function. So this one is linear, because it's a line. But the problem is it is not a function. Because vertical lines are not functions. Right? All right, so that is it. So that's why A is the answer. It's a linear function and it's one-to-one. All right, let's look again. There are another functions question. Any other functions? I'm gonna clear this screen. I don't want to leave it. I don't want to leave the markings on it. All right, 47. Let's see. It's supposed to be other functions questions. All right. This one is a coordinate geometry. All right, so I have functions here on paper one. See, I set these questions as well on paper one. See, they give you this function g of x, and I want g of minus 6. Wait, plug the minus 6 in there. So you get 7 times negative 6 minus 3 over 5. I have to do this with a calculator now, guys. This is 7642. That's negative 42 and minus 3. That's a minus or a plus. I'm not seeing that answer. Minus 3 here over 5. That becomes negative 45 over 5, which is negative 9. So the answer is A. Answer is A. So let's set these questions as well. Let's look at see another one. Look at this diagram now. It's a mapping diagram. Functions again. It says item 51 refers to the following arrow diagram or mapping diagram. Which of the following best describes the function? It is a function. Well, this is the one where they give some formula. So basically, it's to look at the formula and see which one of them will satisfy this. Looks like an x plus 3 to me. You add 3 to this to get this. You add 3 to this to get that. You add 3 to this to get that, right? And the mapping is from x to y. So it looks like, well, this is not so clear. This is it, you know. It's an equal sign right here. Let me zoom it up. This is y equals x plus 3. This is the answer. If you look at it, you can see it. You keep adding 3 to get this value over here. So the y value over here, is equal to the x value plus 3. That's why that is the answer. All right, let's see. There's another functions question. There's another one. This one says, let's zoom it up and you can see it clearly. All right, this one says f of x maps x onto, this is x cubed. X cubed. And this is a domain. It starts from negative 2, negative 1, 0, 1, and 2. And it says, what is the range? It says the range of this function for this domain. So this is a domain. Which one of them is the answer? So basically you're substituting negative 2 in there first. Negative 2 cube is negative 8. This must be the answer, you know? And that's all I want with a negative 8 in it. So this give a negative 8. If I were to mark them, this one give me negative 8. But plug in negative 1 inside here, I get negative 1 cube, which is negative 1. So this one map to negative 1. So see, negative 8, negative 1. Those are two other values. And plug 0 in there, I get 0. So this value map to 0. And then 1 map to 1. It's the one there. And then 2 cube, I put 2 here, so 2 cube. 2 map to 8. So those are my values, negative 8, negative 1, 0, 1, and 8. So my range is this. It's negative 8, negative 1, 0, 1, and 8. Easy enough. All right. I don't think there are any other functions question here. This is transformation. All right, let's look at another multiple choice. Let's look at another one. See if anything has come up. That's 2023. Let's look at 2022. 2022, paper 1, right here. All right, this paper not so clean. All right, let's go. All right, let's see if we can see. We start around 40 something, right? Start around 47 on that paper. So they usually start around the same place. 47. So this is basically the same question, you know? Same question. Which are the following are linear functions? CSEC does that, repeat questions a lot. Which are the following represent a linear function? This again, same question. Same question. And so they give the same question here. So again, G of 6, put the 6 in there. Same question. Give this one again with x cubed. They repeat questions a lot, right? So you can expect that the answer down here is this one. Let's see if there's any other one, any different one. All right, tell you what I'm going to do. I'm going to look at one of the older papers. Let's look at one of the older papers, like 2010. Let's look at 2010. All right, this is 2010 June. Let's look at the functions question on this. See if there's anything to be gained from it. This is 2010 multiple choice. Let's see. Might have to one more paper 2 and we'll call it a day, right? So remember guys, class tomorrow, we're moving on to some other function stuff tomorrow. Look at this question here now. It's a functions question right here with a mapping diagram. You would have found one of these. Look at this question. It said, which of the following illustrates a function? Which of the following diagram illustrates a function? Which one of them is a function? But you can tell me which one is a function? A, B, C, or D? These. Which one is a function? Anybody?
C.
Somebody said C. All right, C is correct. Can want clear to state why C is the correct answer?
Because all of them are mapped once.
Because all of them are mapped once.
All of them what? Come on, be more specific. Don't just say all of them. All of them what? Talk to me now, man. Be more specific.
So all of the domains are mapped.
All right. So remember, to decide if it's a function or not, your focus is on the domain. It's the first thing. You don't care what I'm over the code domain at this level. Is a function or not depends on what is happening in the domain. The first thing that must happen is that all the elements must map And as he said, they must map only one time. So we can identify what caused the others not to be functional. We said the answer is C. Let's look at Y. So we focus on the domain of C right here. 3 elements in C. Each of them have only one mapping coming off it. Even though this over here received 2 mapping, it doesn't matter. Even though this did not have a mapping coming onto it in the codomain, it doesn't matter. It's the domain that decides if it's a function or not. So the 3 elements in the domain, 1, 2, 3, each of them map only one time. This map only one time, this map only one time, and this map only one time. That's why it's a function. Let's look what failed the others. Let's look at what failed the others as functions. In the first one, 2 things failed this one. This one don't have any mapping. You cannot have an element in the domain that is not mapping. If you have an element in the domain that is not mapping, you don't have a function. It's not a function. This one also fails it. Because this element in the domain has 2 arrows coming off it. That makes it a one-to-many. One-to-many relations are not functions. So those 2 values, those 2 elements in the domain cause this mapping to fail as a function. So it's not a function. Let's look at the second one. This is the one that fails this one because it has 2 arrows coming off it. So that one caused that mapping diagram to fail as a function. It is a one-to-many relation right here. Let's look at the last one, what failed it. This again failed this one. Has 2 arrows coming off it. But understand that? But everybody good with that? So mark the elements that failed those as functions. All right, let's look at this one. This is a functions question. They give us this, f of x is that, and I want f of -5. Easy, substitute -5 here and there. And careful with all these word for negative signs all about, right? So this question is about being careful with the negative sign. Let's work it out. Becomes equal to -5 squared. That's right here. Minus, that's this minus, careful, and -5. X is -5. I can bracket it. -1. See all I'm up minus all about the place? This -5 squared becomes a positive 25. This minus becomes a +5. -1. This is 30 minus 1 is 29. This answer is 29. Answer is D. That's another functions question on paper 1. Let's look again. There are any other ones? Here's another functions one. Similar to the one that we did before. It says, which are the following best describe the function? Again, it's an x plus 3, plus 3, plus 3, plus 3. So the y is equal to x plus 3. This one. They don't call it y this time, it's f of x. Don't matter. F of x is x plus 3. Over here is still f of x is equal to the x value plus 3. All right, that is that one. Let's see. There are another function. No other functions on this. What time is it? We have 8 minutes. All right, another function. Let's go back and do one more paper 2 question, and then we go. All right. So you see that this function also on the paper 2. Let's look at 2015 9B. Let's see that's an interesting question. Let's look at 2015 9B. Let's see what kind of question that is, and then we shall call it a day after that one. We did start a couple of minutes after 11. We'll try to do about 2 hours in these sessions, right? To revise and practice. And after I'm done, guys, remember, I want you to redo the questions. Watch over the video. Redo the questions on your own. 2015, right here. All right. Let's do this question. And then we'll call it a day. All right. 9B. All right. We get to that at some other point. Or let's just finish off with this question. All right. Let's finish off with this question. Not a problem. This question gives us two functions, f of x and g of x. I really wanted us to do at least one rational function before we finish still, inverse of a rational function. One like 4x minus 5 over 2x plus 3. Really wanted to do, oh, but we do one at the beginning of the class. So it's okay. I did do the inverse of one at the beginning of the class, from the class. So it's not a problem. We're okay there. Yeah, we did do one. We want to see some more of that. Next week, we'll do the undefined. When a function is undefined, all right? So f of x and g of x, this question wants g of 5. So g of 5 means that we'll put 5 in the g function right there. All right? A common mistake for person is to put the g of 5 and put it in here. Why? Why do that? Because this appears first on the paper. All right? Don't make that mistake. Right? The 5 is supposed to go in the g. They want f of 5, they put it in there, but they want g of 5. So we put the 5 in the g function. So this becomes equal to 5 squared minus 1 over 3. I replace the 5, that's the 5 right there. 5 squared is 25. 25 minus 1 is 24. This becomes 24 over 3. 24 over 3 is 8. That's it. All right. Next thing I want is write an expression for f to the minus 1. This is f. I want the inverse of it. Easy. We're going to start by saying f equals 3x plus 2. We're going to inverse it. The f becomes x because it is range, and it now becomes domain equals 3 times. This x is domain is going to become range in the inverse function. So put the minus 1 on it because this is range in the inverse function. This is range in the function. This is range in the inverse function. Put back the plus 2. So I've interchanged the domain and the range. Want to leave this as a subject? No, easy. Transpose the 2 first and subtract it and then divide under the 3. So we're going to get f to the minus 1 equal x minus 2. We'll carry over the 2 becomes minus 2. Divide the 3 under there. Divided by 3. This is f to the minus 1 of x. So we can write it, i.e. f to the minus 1, putting by the of x now, is x minus 2 over 3. Done. This is a very easy question. Maybe we need to do another one after this. I'll finish this one so quickly. Then they want us to find g of f. I must express it as factorized, in a factor form. They want g of f. G of f. So remember, g of f means the f into the g. Let's write it out. G of f means f into g. Let me construct it here. The g of x, remember, was, what is it again? It is x squared minus 1 over 3. And the f of x is 3x plus 2. And we're trying to form f into g right here. So g of f of x, we say that is f into g, first function into the second function. And so taking all of f, I'm going to bring it and substitute it into the g. Right here where the x is. All right. So we're going to get, with that substitution, we're going to get 3x plus 2 r squared minus 1 over 3. But the question said the more answer like this, factorized. So we're going to expand it out and simplify and factorize. Let's see what we get. Expand this now. Remember, we expand a perfect square and we get 3 terms, right? We're going to get 3 terms. Let me shift this over a little bit. Make it a little smaller, so a little bit more space. All right, so when I expand this now, when we expand the perfect square, get 3 terms. So this becomes equal to, first term squared is 9x squared. Then twice the product of a 2. Remember, twice the product of a 2 means that you multiply these two things first, you're going to get 6x, and you double it to 12x. Then the second term squared, 2 squared is 4. And it's subtracting this 1 all over. This is 9. This 3. Consolidate the values on the numerator. We get 9x squared plus 12x plus 3. 4 minus 1 is 3 all over 3. Then all of these can be divided by 3. So divide each of them by 3. Let me do it here. We divide each of them by 3 becomes equal to this divided by 3 is 3x squared. This divided by 3 is 4x. This divided by 3 is 1. Easy to factorize because prime and 1. Factors of 3x squared is only 3x and x. Factors of 1 is only 1 and 1. So let's test that. 3x and x, 1 and 1. Everything positive. Signs are the same. They are both positive. Positive, positive. Let's double check it. Far product is 3x. Near product is 1x. 3x and 1x give me the middle term of 4x. Let me say them good. Everything good. Those are my factors. All right. Put us to one more question. More maths equals better maths. So let us do one more. Let's try 2016 number 9. Let's see if there's anything interesting on 2016 number 9. I'll finish off with that for sure. For sure, for sure, for sure. 2016 number 9. Where is 2016? 2016, right here. 2016 number 9. Oh, 2016 number 9 is for next week, guys. Yeah. This is for next week. I want to be doing a topic called inverse of a composite function. We're doing that tomorrow. These things. We're doing that tomorrow. So 2016 number 9 is for next week. All right. I want to do one more question before we finish. So bear with me. Let's do 2017 number 4. 2017 number 4. Where are you? 2017 number 4. And then we'll call it a day after this one, right? Call it a day. All right. Yeah, nice if you want to just finish up with. Let's just finish up with this one for the day. All right, guys. Remember, you are to redo all the questions I did. Do all of them. Go back over the video. Redo the questions. Use the video to help. All right, check your answers. More maths equals better maths. Study hard, pass easily. What I said, all mathematical principles can only be fully understood by solving many questions. You have to solve many questions if you want to fully understand these things and get the questions right, regardless of how they are set. All right. So they give us just one function here, f of x, and I want f of 3 plus f of minus 3. So this is equal to, put f of 3 first. I want to put the 3 in there. So I'm going to get a third, 3 minus 2. And we need to add the f of minus 3, so plus f of minus 3, now put in minus 3 in there. So I'm going to come a third, minus 3, and then still is minus 2. Answer is -4 now because this and this wipe out each other. And they have minus 2 and minus 2 equal -4. If you want to work it out, this is 1. Minus 2 is the minus 1 now, but this is become a minus 1. So it's plus minus, which is minus 1. And then this minus 2. So this 1 and this minus 1 wipe out each other. And then minus 2 and minus 2 is -4. Answer is -4. So given 2 marks for that. This part. Calculate the value of x for which f of x is equal to 5. If f of x is equal to 5, means that we're putting this thing equals 5 to solve. All right. So we're going to put the third x minus 2, that's f of x, which is equal 5, and solve to find x value. Transpose this 2 further becomes plus 2. So we're going to get a third x equals 7. 5 and 2 is 7. I want to multiply by the 3. Multiply the 3. So x equals 7 times 3, which is 21. X equals 21. Easy question. What a good so far with this one?
Yes, sir.
All right. Moving right along. Then I want f to the minus 1. Easy stuff. What was f again? F is a third x minus 2. Easy free question. Start by saying f equals a third x minus 2. Let's leave off x for the time being. A third x minus 2. I want to inverse it. Inverse it. The f becomes x. A third. This x becomes f to the minus 1. Minus 2. I want to make this a subject. Careful now. Cure the 2 first and add it. But this time we're going to multiply with a 3. Normally I would have like 3f. I would divide by the 3. This time we have to multiply up this 3. So let's do step by step. Cure this first. We're going to get x plus 2 equals a third f to the minus 1. Then to move this third, I have to multiply by 3. Right? Or it's a multiply by 3. So we're going to get 3 times x plus 2 equals f to the minus 1. If I continue up here, we can expand this. I don't have to expand it. We can just write the f to the minus 1. Put in by the of x now equals this thing, which you can expand as 3x plus 6. That's the answer right there. This is the answer. Right there. Anything else on this question? Nope. That's it. All right, guys. So you see that this topic really very easy. Sometimes I set the question a little bit way around with the same basic concept, right? Just need to practice, practice, practice. All right. And I will see you guys tomorrow on Monday in class. We will do the next part of functions. Okay, everybody good?
Yes,
All
sir.
right. All right, good. All right, have a wonderful rest of the day. Make sure you keep practicing. All right, bye everybody.
Bye, sir.
All right, cool. I'm gonna end it now. All right, bye-bye.